So our video demonstration of the Xyztech Sigma bond tester. It's running off a Dell PC with 2 monitors. Everything here is run off 110 volts, the PC as well as the actual test unit. The power on button for the test unit is over here on the side. You want to make sure your green light is on. For your PC, you have a mouse as well as a keyboard. And for the tester, you have 2 joysticks, one on the right side, used for test. It's got buttons to test, vacuum, null, etc. Left side, you have your grading, 1, 2, 3, as well as a park and a lower limit set. I'll talk about the, you do have a stage here that's set up on here. It can be removed by just removing the handle here. As you can see, it lifts off. You just want to make sure you're in the up position, which we are. You can go ahead and easily replace it. Just lock it down. Let's talk about the PC first. We've got it powered up. I'm just going to go ahead in and hit settings, system. And you can see that it's using 2 displays, one up top, 2 on the bottom. And then we'll just do the about. And look at the OptiPlex 3050. And as you can see, it's running Windows 10 Pro. We'll start up the software by hitting the upper icon there, start Condor Sigma. Well, the software is loaded up. Just want to point out everything. The PC and the unit runs off of 110 volts AC. Okay, here it's asking you to, saying the Sigma should be home. Should you proceed? We'll go ahead and hit yes. And here there's no password set. I'm just going to default to supervisor. You can see the using the joysticks, you can position your stage underneath. And then to do your rotation, this is a rotating a load cell here. That's a die shear, and you can see you can rotate it. Like going left and right with the right joystick here, and then you can bring the head up and down with the Z-axis. If you want to hit a lower limit, you just go ahead and move to that position and hold lower limit. Stop. You can see it won't go any lower than that. You want to bring the head up, you'll go ahead and hit the park, and it brings it up. This has a rotating measurement unit, and there's currently there's 4 test cells that are loaded in there. It has the capability of having 6 different test modules. What I do here is right now we're set up for the rotating shear. I'm going to go here to the machine settings, and I'm going to show you. During power up, it'll initialize and reads the cells that are in there, the measuring units that are in there. And you can see we have the rotating shear of 100 gram force. We got a pull of 100 gram force. We also have the pull tweezer of 100 gram force, and then there's a larger pull of 10K gram force. 10 kilogram force. Okay. So here's where you look for the one that's purple, highlighted in the pink. That's the one that's currently in position. So what I want to do here is I'm going to go to SPC by using this arrow up here. All these buttons are functional. I just want to show you that too. If you want to use them on in software, or you can use them down on the keypads, and you see it'll go pink. So for instance, say you had an application where vacuum was attached, you go ahead and turn the vacuum on and off. What I want to do here is I'm going to show you the rotation of each one of the modules. Right now we're at rotating shear. You do that by selecting any one of the 4 that are available. We'll go ahead and do the pull. This is actually being used as a push. And it came in with this push setup on it. I don't have a hook, so we're going to go ahead and when I demonstrate it, I'll do a push test on it. But it's either a wire pull or a push. Okay, I'm going to move to the tweezers now. And this is a rotating tweezer. You can see it does move in this rotation. And that's 100 gram force. And then finally the 4th one is the this is not the standard hook. I had this hook here available to do our test. But that's our 10 kilogram force pull test. So what I'm going to do is I'm going to set up each individual test that I came up with in order to test each one of these cells. We'll go ahead and start with the tweezer first. So let me put it in a tweezer position. Oh, the other thing I want to point out too is this unit has 3 cameras, and by hitting the cockpit button here, you can see that there is a left camera, there's a microscope camera, as well as a right camera. And just to show you by moving my hand underneath, you can see that it's not in focus, but that the cameras are working. Okay. So we'll close out on this, and then what I'll do is I'm going to just use the microscope camera, and we brought it down here to the you can move between the stages, but in between the displays. So I just brought that down here, basically. Yeah, click on that. And then I'll just slide it down. Okay, you control your lights for your cameras here. That's your gain. Here's your exposure. That's an auto mode. Oh, we're not in focus right now. So what I'll do is I'll demonstrate that when we come back. I'm going to go ahead and set up the tweezer test that I came up with using a 50 gram weight with a wire attached to it. And I'm just going to pull this at 49 grams just to show it as a non-destruct test, and that the tweezer is actually open and closing, and that it's coming up with a reading. So when we come back, I'll go ahead and have that ready to go. Good. All right, now I'm set up for the with the 100 gram tweezer pull test. I just want to point out another thing here too. In this second column here, right where the arrow is, if you open that up, you do have various programs that you can choose from. Right now, the one I had set up was the 150 micron aluminum wire test. If you want to see what that test entails, you'll go ahead here and it'll tell you, here's the parameters for that test. It'll tell you the test distance, test speed. Right now, I am not doing the destruct test. The destruct test will take that force limit out. So when I hit that, as you can see, I have it set for 49 grams. So it's basically a non-destruct test. It'll pull that 49 grams. I don't think it's holding at all, no hold time. And then the other thing is I have the tweezer set to open at the maximum as well as close, and with a tweezer force of 500 grams. And there's a test delay of 1. And I have it returning to the start position. Okay, so this is where you go ahead and set up your parameters for each one of the tests. It's true with all the cells. I mean, you could look at it, there'll be a list here that you can choose from. The other thing with the camera here, you do have various settings. I've got it in this box here. As you can see, the image changes. You got a high resolution image, or higher and lower mag. To position the camera, you go ahead and use your, you can use your up and down here. I just want to point out one thing too. This camera does slide out of the way if necessary, and just slowly bring it back in here. This is your focus knob here. This knob here moves it right and left. And then the one in the back will move it in and out. Okay. So we have it pretty well centered here. I don't know if you can see that, but here's our little wire loop that I have up on there, and here's our tweezers. You can set your gain, your image gain here, and your exposure can be set here. Or you can just go ahead and put it in auto mode if necessary. You also have this function up here where you can adjust the intensity of the light. As you can see, I lower the light almost completely. So you play around with that, you get the best image you can see on the screen. It helps you out. You can see I'm going to move that loop in there. It's kind of on an angle, so you got to be careful that you actually got it in place. And so what I'm going to do is I'll just go ahead and hit the test button. Looks like I missed it. Yeah, you got to kind of get used to it. You got to wait for this test to complete. It'll open the tweezers up. But at least there you can see that the tweezers had closed. It's just I didn't hit the loop properly there. And it's going to return to the start position. So you kind of got to get a little used to this, figuring out where it is. It may not be. I'm moving it back and forth. You want to, so you can do a rotation if necessary on the tweezer head. This is not ideal, but it's a test I came up with. I don't have any samples here that I can actually pull the heavy wire other than this. The thing I wanted to point out too is if you look over here, and you can go ahead and use your keypad once you're close if necessary by using the arrows. So you want to have this box green here, and then I can use that to move left and right, back and forth. I think the best thing is, let me just look up under there and see where it's at. Yeah, it's a real slow movement. Bring it down a little bit. Alright, so let's try to test from there. Okay, you can see that it did grab the wire. If you look on the camera here, you get a zoomed in view. And you can see up here, it's telling you how it's moving, that the z-axis is moving, and here's your gram force. And then your statistical data will be put up here, and it's looking at the result type as a peak force. ton of a long test, but okay, so now they're showing you your value and frequency, and then here's some of the data that you can use there. Well, there's nothing here now. So what I'm going to do is I'll go ahead and do, let's do 10 repeats on that by changing this value here to 10. And what I want to do is I want to speed that test up a little bit, so I'm going to go ahead and let's only pull this like 15 microns, 1500 microns. And we'll increase the speed to, let's say 7. Okay, so what I'm going to demonstrate here is it's going to do actually 10 pulls and repeats, and just to show that it's working well. Let's get out of this, hit OK. So it did one there, open, close, now it's pulling it again. That's the third test. If you look at the data here, it's going to show you that it's actually pulling at 48 grams. Like I said, I set it to a non-destructive 49. More or less reading the same reading, 48.51, 48.46, 48.47 again. And again, this is your data being generated. So this is just a demonstration of the tweezer actually doing a pull test on a wire. And it looks like the load cell is working pretty well. I'll show you, you can do, this software is very intensive. There's a lot of different things you can do. I'm only showing you a few of the things. You can change your images here. You can go back and look at, I had generated a little, it's not showing me that. You can go ahead and do a, set your camera parameters with this box. I'll go ahead and change some of the camera images. This is a little more blown up. If you need to focus it, again, it's this knob here. It's just moving your microscope up and down. So as you can see, the tweezer test is working the way it's supposed to. I believe it, yes, it did. It finished its 10 tests, so it did 10 pulls on the same wire. As you can see, the force stayed the same. All right, I'm going to go up to the park position. I'll remove the test sample here. And I'm going to rotate, like I said, I set this one up for the heavy pull. And again, this is a hook I was able to use that I had here, but it's not the exact one that you would be using. You'd have to purchase that on your own. So I'm just going to put this 2.5 kilogram test weight up on the other thing you can do too is you can lower your zoom. So for instance on here, I'm not going to change this camera much because I think it's set up for the other two. I'm just gonna do a visual on this. I'll bring down the hook. As you can see, I can rotate it. I'm just move this to the right. Let's bring down the hook to here. Now let's look at our, I created a program here called bit test of 2.5 kilogram test. And what I'm going to do here is I'm going to do, again, a non-destruct pull of 2.4 kilogram force, and it's going to return to the position. So we'll hit OK on that, and I'll do, let's say, I'm going to do 10 repeats on this. I'm going to call it a new sample. So I'll get rid of all this old data. And then we'll go ahead and hit test on it. So you can see here that the load cell does have a reading, and the number is here. So it's pulling 2.4 and then going back to the start position. And you can see here's your peak force, 2.402, 2.403. Again, here's some of your data. Okay, so it's showing that this load cell is working properly. It's doing a non-destruct 2.4 kilogram force test. And so that we did our 10 tests. You can see that it's just about the same for all 10 of the tests. Okay, so let's move on. Time's sake, we're trying to get as much shown here as possible. So we'll go ahead and bring this down. Slide it over, and we'll remove this. I have a little sample here where I can do the, I'll do the push test first, and then we'll do a ball shear test with the other two modules. I'll turn that up a little bit. Go ahead and rotate it to our, let's do the push test next. So we're going to use the 100 gram push pull load cell. Like I said, this is the one that you would have a hook on if you wanted to do a wire pull on, but I don't have any hooks available. So we're going to go ahead and let's do a new sample on this. What I'll do is I'll bring the work under the tool. I'll bring that down. You can see it's off a little bit because it was set to do the other test. So I'm going to reposition the camera. See, it's got a little go up to higher mag. Where is that high mag? That's the highest magnification, I believe. I'm going to continue to bring this down until just above. I'm going to reposition the camera. Focus is here. let's for instance do a push on that die there as a test. So what I'll do is I'll bring the die up underneath it. This does rotate it, so if you had a hook on it, it would rotate the hook for you. But in this instance, you don't need that functionality. Let me just bring that above. Let me just test to make sure it's going to actually touch it. Yeah, so you can see where it's just about ready to touch. And this test is just going to go down and push on it at a certain force and then lift up. So look at the data for that test. We'll go ahead and hit this button. The test is named push. It's gonna, the test distance is minus 500 microns. The speed is here. And it's gonna null the sensor before test. It's gonna put a force of 50 gram force on it. And then it's gonna return to the start position. Okay, so that's the test. We'll set it up for, I did 400 repetitions on it. But we're gonna set this up for 10. And then we'll go ahead and hit the test button over here. Okay, so it did the 10 tests already. Let me see, what was the program here? I may not be maybe too high up. The speed is here. We want to put on 50 gram. I don't think I was probably too. Let's do increase the test distance from where we're at here. I think we're just barely touching it. I'll put a 10. Yeah. 1,000 microns there. Let's hit enter. And let's try to test again. Let's call it a new sample here. So we'll use that data. Yeah, so now it's pushing down far enough because we're now getting the 50 grams. Let's do it. Again, this is our push tester showing that the load cell is working properly. The maximum force on that's 100 grams. And we're putting 50 on it now. It would can also be used as the wire pull if you had the right wire pull apparatus set up on it. Again, here's your data. Okay, so just looking over here, you can see that it's 10 tests, 49.6, roughly 7, somewhere around there. And that's your distribution there. All right, so finally what we'll do is let's go back to the park position. Get the tool up out of the way. We'll rotate to our final demonstration load cell here, which would be our rotating shear of 100 gram force. And I'll just go ahead and push on that die that we were just push from the side, lateral push on it. If you ever need to home the rotation, you can hit the home button here. If you watch the tool, I'm going to take it out of the home position and we'll put it back to home. Okay. Here, the previous test that was set up, which I ran, is up in there now. But to look at the data, we'll go ahead and see that it's a 25. I have it set for the 25 micron ball wire. Oh, actually, you can see there are some balls here, so maybe I'll just go ahead and we'll do a ball shear on this. Of the distance is 100, speed 50 microns. It's going to do a destruct test. You see, this is all your data here. It does a touchdown, so it'll touch down and lift up off the surface. So this is one of the tests it can do. So what we'll do is we'll accept that, and this will clear the old data, and we'll set it up to do a ball test on one of these. It's a little hard to see, but these are balls that I placed on the sample a while ago. So we'll go ahead and bring that down. Magnification over there? And I'll bring the magnification up for this particular test, so you can actually see the ball. Let's see if we can see it. Change the magnification on this so we don't run the tool into the work. On that. Let's go back to the home. So you gotta position your camera and focus it, since we're doing very small sizes now. And you want to brighten the image up a little bit. You do get a reflection from the light on the tool. So. But basically, here's your wedge tool, or your shear tool. I'm gonna move it back a little bit. Here's a ball right here. Bring it down, make sure we're aligned. I always like to test it first. We are on an angle looking in here. So. It looks like there's a ball stuck on it right now. So what I want to do is I want to put that image in the center. Let's go up to a higher magnification on that, high resolution. I think that's a ball there. There's a ball that's stuck on here, but I'll go ahead and hit the test and you can watch it go through its test procedure. So it's going to touch down and then lift up off the surface. And then it's going to move. Yes, it did. There was a ball on it and hit the ball. And it looks like the peak force was 39.53. Can't repeat on this because it actually broke the ball. Let's look for another one. We'll go ahead and do that. Do another sample on that. As you can see, you can rotate your shear tool. Looks like there's one right here too. Okay. See, it moves a lot. This is where you want to go ahead and use your keypad, your arrow. And again, I'm going to activate that by hitting that button there, and then I could just go ahead and move it left or right using the keypad. So, we look pretty good now. I'll just bring it over this way a little bit. Okay, so this will be the last step. So it's going to drop down, touch the surface, and there's a ball right there. I don't know if we can focus that any better. You can see it there. And we'll go ahead and hit the test on it. There it is. So that's your ball shear test. And here's your data. As you can see, the second one was 52 grams on that. So that's our demonstration of the actual 4 load cells that are loaded on the Xyztech Sigma. And just to show you that it's operational, the stage moves, the software works.